Let's talk about two special types of functions, even and odd function. So we'll begin with even functions. Suppose we have a function given by f, and this particular function is a function of x. Now, what we can do is we are going to replace the value of x with negative x, and this is going to give us f of negative x. If on doing so, whatever value we get, if it gives back the original function f of x, then we say that our function f is even. Now this is going to be true for all values of x. So for example, we'll have, suppose we have the function f of x is equals to cosine of x. So if we substitute the value of x with negative x, so that gives us cosine of negative x, and cosine of negative x is positive cosine of x, and we see that we get back the original function plus cosine of x, which is simply f of x. So that means f of negative x is equals to f of x. In such a case, we can say f is an even function. Now let me give you the formal definition for an even function. So f is said to be an even function of x if f of negative x equals to f of x for all values of x and negative x belonging to the domain of a function f. Such a function, an even function, is symmetric about the y-axis. This is one of the fastest way to check graphically if a given function is even or not. So what will that? Let's take the graph of our cosine function. So our cosine function is given by, we have, this is our cosine function. So here we see that if we consider a mirror which is lying on the y-axis, then we can immediately see that the right hand side of the graph is exactly equals to the left hand side of the graph. That is, the graph will be symmetric about the y-axis, and in that case we can say that our function, which is cosine of x, this is a even function. A quadratic function, or a parabolic function to be more precise, which is given by x squared, this particular graph is also an even function, because if we draw a mirror about the y-axis, so we can have as a mirror symmetry about the y-axis. The left hand side of the graph is exactly equals to the right hand side of the graph. Now let's talk about the odd function. Now what we'll do in the case of odd function, we'll start with a function given by f of x. Then we're going to replace x with negative x, and on doing that, if we get f of x but this time with a negative sign, then we can say that f is an odd function. Let us consider the example of a linear function which is given by f of x is equals to x. If we substitute x with negative x, so on the right hand side x will be negative x. Now if we take negative as the common, so what is left with x? So x is simply f of x. So we are getting the condition that f of negative x is equals to negative of fx, and this means f is a odd function. Okay. Let's try to define an odd function. So f is said to be an odd function of x if f of negative x is equals to negative times f of x for all values of x and negative x belonging to the domain of f. Such functions, that means if a function is odd in nature, then those functions are symmetric about the origin. Let's say we have a graph given by this particular shape as shown on screen. which is, now I'm telling you that this particular graph is a odd function. Now, without going through the definition, what we'll do is, like, we'll consider a point on this graph on the first quadrant, and then we're going to consider a point on the third quadrant. But it has to be we have to be very careful about it when we're choosing this particular point. It cannot be any random point. What I mean by that, if we choose x comma y, then what we are going to do, we're going to replace x with negative x and y with negative y, and we're going to find that corresponding point on the third quadrant. And when we join these 2 points, we'll see that it will be joined by a straight line, and that line is going to pass through the origin, and that is going to tell us this particular graph is going to have a symmetry about the origin. And another way of looking at it is, if we rotate this graph by 180 degrees, it's going to have its original form. So this is an example of an odd function, but this is like a better way of looking at it. So what we do, we'll start with any point on the first quadrant, x and y, and we'll replace x and y with negative x and negative y, and find that, or locate that point on the third quadrant, which will be lying on that particular graph. And when we join the 2 points, it has to pass through the origin. Now let's do a few problems that will help us classify between odd functions and even functions. So here we are given the function f of x is equals to sine of x. We have to check whether if this particular function is an odd function or an even function or neither. So the best way to do it will be replace the value of x with negative x. So that gives us sine of negative x, and sine of negative x is simply negative sine of x. And we know the sine of x is f of x, so let's replace this. So we're getting it negative times f of x. So we are getting the condition for a odd function. So that means our function f of x equals to sine x is an odd function. Right. So let's try to graph it. So we know that the sine function is given by this particular shape, and there are 2 things we can quickly look from this. We can extract 2 key information from this particular graph. We can pull out, which will tell us this is an odd function. The first will be, like, if we can rotate this entire function by 180 degrees, it is going to have the same form. And another way of doing it is, like, we'll consider any random point on the graph on the first quadrant. So let's suppose this is the point x comma y. Then what we'll do, we'll replace x with negative x and y with negative y, and find a corresponding point on the third quadrant. So that will be negative x, negative y. And when we join the 2 points by a straight line, we'll see that the straight line is always going to pass through the origin of the graph. That means the center of the coordinate system. So this is symmetric about the origin, and hence our graph of sine x is an odd function. So here we have f of x is equals to sine x plus cosine x. Now we already mentioned that our sine x in the previous problem, we found out that this is an odd function, whereas cosine of x is an even function. Now what we are doing is, like, we have an odd function added to an even function. The question is, what was the nature of the sum of those 2 functions? Is the sum going to be an odd function, or is it going to be an even function? So what we'll do, we're going to replace the value of x with negative x. So that gives us f of negative x is equals to sine of negative x plus cosine of negative x. The sine of negative x is simply negative of sine x, plus cosine of negative x is simply cosine of x. Now, no matter which way we arrange this particular expression, it's never going to be equals to our original function f of x. So here we will say that f is neither odd nor an even function. So problem number 3, here we have the function x times e raised to the power of x minus 1 over e raised to the power of x plus 1. So let's try to check the nature of this particular function. we'll begin by replacing the value of x with negative x. So that will give us negative x times e raised to the power of, we have positive x, so that will be negative x minus 1 whole divided by e raised to the power of negative x plus 1. While this particular expression does not look anything like our original function f of x, we're not going to stop here and say that this function f of x is neither odd nor even. What we'll have to do is we'll have to do a little more simplification. So let's do that. So let's say we have negative x times, so e raised to the power of negative x, so that can be written as 1 divided by e raised to the power of x minus 1 whole divided by 1 over e raised to the power of x plus 1. Then we'll simplify both the numerator and the denominator. So that will give us negative x times 1 minus e raised to the power of x whole divided by e raised to the power of x, and the entire thing divided by 1 plus e raised to the power of x whole divided by e raised to the power of x. So we can cancel out the e raised to the power of x from the denominator of both the two expression in the numerator and the denominator, and this is going to leave us with f of x, negative x, is equals to negative x times 1 minus e raised to the power of x divided by 1 plus e raised to the power of positive x. Now we take this negative sign and multiply it to the numerator, so that will give us e raised to the power of x, and we already have x here, minus 1 over e raised to the power of x plus 1, and this expression is exactly equal to our original function f of x. So this is f of x. Now since f of negative x is equals to f of x, I can write down thus f equals to x times e raised to the power of x minus 1 divided by e raised to the power of x plus 1 is an even function. So let's do another final problem. So here we have the function g of x is equals to x squared minus the absolute value of x. So what we'll do, we'll first begin by replacing x with negative x. So g of negative x will be negative x whole squared. Please be careful here while you're writing negative x whole squared and not simply write it as negative x squared. So because this is not equals to negative x squared, because negative x whole squared is x squared, and in by no means negative x squared will be equals to x squared, so they're unequal. So please be careful here. Minus absolute value of negative x. So negative x whole squared will be x squared minus, now since we have absolute value of negative of x, so that's simply positive absolute value of positive x. That means the same thing. So this gives back the original function g of x. Now since, we'll write down since g of negative x is equals to g of x, so our function f, now we have considered g here, so g is a even function.